So good afternoon everyone. Today I'm going to be talking about two subjects that a few years ago would not commonly have been associated with each other: climate change and legacy landfills. I'm sure many of you have heard me talk about closed landfills before, and I don't mind being referred to as the closed landfill lady. But before March 2019, when the Fox River landfill was exposed by a storm event, I'd not really put much thought into how climate change might affect these sites. We're used to assessing the risks that legacy landfills pose to their environments, but this time we're needing to assess the risks to closed landfills from the new hazards that climate change brings. Managing these risks is incredibly important for the protection of our environment, and as we saw with the Fox River landfill failure, and increasingly with other closed landfills around New Zealand, a little bit of rubbish goes a long way. Clearly, we need to do more to address these risks and protect not only our natural environment, but the economies of these communities and our clean, green environmental reputation. So today I'm going to talk about some of the reasons why this is such a problem for New Zealand, how big the problem might be, and then how we can go about addressing this in a sensible way. Landfill practices in New Zealand have changed a lot in our short history. We can now be proud of the standard to which our landfills are constructed, but it has been a long road to get here, and the majority of our legacy landfills do not meet current engineering standards. Many aspects of how landfilling was done in the past are now increasing the risks to these sites from climate change hazards. Location is a prime example of this. Landfilling commonly occurred in estuaries, old gullies, river channels and quarries. Landfilling was commonly used as a way to reclaim land or build land up to create more usable space. And these activities resulted in many of the sites being located along shorelines or in natural overland flow paths, increasing the exposure to climate change hazards. On the screen you can see the extent of landfilling and reclamation along the Onehunga foreshore here in Auckland, and on the right is an example of the channel of an estuary being filled in through landfilling activities. Landfill construction, or lack thereof, is also a key concern. Liners were nominal or non-existent, and often little thought was given to edge protection or cover systems on completion of filling. For sites on the coast, bunds might have been constructed in an attempt to contain the refuse while filling was going on. However, these would not have been constructed to last for 50 plus years, and they certainly would not have considered the future impacts of climate change. Equally, cover systems comprising locally derived natural material were commonplace, and the competence and thickness of the material would have been dependent on what was available at the time. These features mean that legacy landfills are unlikely to have much resilience when they're exposed to the increased pressures that climate change brings. Filling practices are another concern. In the past, landfilling commonly occurred by end-tipping material onto an existing surface. This surface might have been the mudflats of an estuary, the porous floor of an old sand quarry, or simply over the edge of a gully. Minimal compaction would have been carried out. This is likely to result in the material having very little strength and being susceptible to differential settlement and erosion. Increased pressures from flooding and more intense rain events can easily exploit these flaws and result in refuse becoming exposed. Waste type probably doesn't increase risks from climate change, but it certainly contributes to the impact a failure from a landfill might have on the environment. Municipal waste is likely to be the most obvious impact on the environment. Waste which postdates the 1960s is likely to have a high proportion of plastic, which, as we saw at Fox River, is highly mobile and very hard to clean up. But other waste types are also of concern. Construction and demolition waste could release timber and asbestos into the environment. Industrial waste could contain tyres and metals, which present a sharps risk, and contaminated soils and hazardous substances are also of concern. Even so-called clean fill sites need to be thought about. Unless these sites were well supervised, they could contain small pockets of municipal or commercial waste. So it's difficult to say how many closed landfills might be exposed to hazards, as the availability of data around the country is variable. However, it's not hard to imagine that the number of sites in this group could be significant. Given what we just discussed in terms of landfills commonly being located in gullies and along coastlines, it's likely that there's a significant percentage of these sites are located in areas that could be impacted by sea level rise, storm surges, or increased flooding. In 2019, Local Government New Zealand prepared a report on the vulnerability of local government infrastructure to sea level rise, and they identified nearly 150 closed landfill sites which were vulnerable to a 1.5 metre sea level rise. This seems like a small number, but it only represented a small subset of councils across New Zealand. If we think about the sites that were identified for the Auckland region, for example, the number they presented represents over 40% of the landfills within that region. If you were to extrapolate this over the councils around New Zealand, it doesn't take long to come up with a very large number. Also, the LGNZ work only looked at sea level rise. Their numbers didn't include sites that might be vulnerable to other climate change hazards, so undoubtedly the list is much, much longer. It seems like every week there's another article in the media about a closed landfill discharging waste into the environment. The potential environmental impacts of hundreds of these sites releasing waste into our rivers and coastlines is enough to keep you awake at night. So clearly these types of discharges can have significant detrimental effects on the environment and on our communities, but there are other implications that need to be considered. There's a significant financial cost associated with managing these risks, and that's either with preventing them from happening in the first place or from cleaning up a failure if it does happen. There's also indirect costs if local businesses and communities are affected by a failure. If the solution for these sites was to remove a large number of them and redeposit the waste into operating landfills, this is going to create problems of its own. The waste would take up precious landfill void space earmarked for future waste generation. And this issue could be even more pronounced if we're talking about closed landfills in remote areas. Operational sites in remote areas are likely to have a small volume in the first place, so adding additional waste to them from the remediation of closed landfills is likely to significantly impact their future operation. There's also the ETS obligations and the waste disposal levy to be factored in. The way the ETS legislation is currently written, redisposed waste would be subject to the ETS obligations and would also attract the waste disposal levy, adding additional cost to the rehabilitation of these sites. So what is the solution? Clearly, it's not a one-size-fits-all. We're not going to run around and excavate every closed landfill that's close to a river or coast and put it into another landfill, but nor can we ignore the hundreds of sites that may be poised to have a significant impact on our environment. The solutions need to be risk-based and backed by good science so that closed landfill owners can be sure that they are focusing their time and money on sites that present the highest level of risk. So assessing risks from climate change is definitely not my forte, but in a general sense it follows the same model of likelihood times consequence that we're familiar with for any risk assessment. One of the key differences, however, is that we're assessing risks associated with a potential future state rather than a known quantity, for example, the levels of arsenic in the soil. There are also multiple hazards that need to be considered. Sea level rise is the obvious one, but other risks such as increased flooding, either from the sea or from rivers, and increased temperature and wind conditions are also hazards that could be associated with climate change. In relation to closed landfills, this could play out like this. If we consider sea level rise, the first step would be to identify your site and define whether it's within a set increment of sea level rise. Next, you need to consider how well the landfill is protected from this hazard, and then consider what the consequences might be if a failure were to occur and the landfill were to release material into the environment. The calculated risk for the site will depend on all three of these components. If they all have a low probability, then the risk will be low. If one or more of these factors has a high probability, the calculated risk will be higher, and the higher the priority should be for carrying out remedial works. Using a defined process to assess risks to closed landfills has several benefits. It presents a clear, scientifically justified process to assist with decision making, and it makes communicating those decisions to stakeholders easier. It also provides consistency where lots of sites are considered, and it ensures that sites are assessed equally. But the implementation of a risk assessment requires data. The more data, the more robust the assessment and the more informed the decisions can be. Unfortunately, there are lots of gaps when it comes to both climate change and closed landfills. One way to address this would be to go out and collect every bit of information we can about climate change hazards and carry out extensive investigations on all of our closed landfills. Then we can use complex tools to evaluate the data in a million different ways, and we can make decisions accordingly. This will be fantastic, but it would also be very expensive, and in most cases it would be unnecessary in order to determine the level of risk presented by an individual site. Instead, a staged, iterative process of data gathering and evaluation is recommended, with the ultimate objective of being able to make good decisions about the future management of closed landfill sites. So what we've found from recent projects we've carried out is that there are some key pieces of information that are likely to provide better value for money than others. Information that can be fairly easily obtained and can really help to evaluate risks from climate change hazards. The quality of the cover material, for example, is a great place to start. You can start gathering information about the quality of your cover material simply by walking around a site. Exposed refuse, cracks, dead vegetation, these are a sure sign that the cap is not as robust as it might be. Dig a little deeper with a spade, a hand auger or an excavator, and you can fairly quickly build up a picture of how much protection there is from hazards such as inundation and erosion. So understanding the size of the site and the waste type is also important for understanding the potential consequences of a failure occurring. This information can be gathered from historical aerial photos and from site records. Failing that, a few days with an excavator will tell you everything you need to know in order to understand what a failure might look like on the adjacent environment. Small sites are probably less of an issue. However, if they contain municipal waste that postdates the 1960s, they are likely to contain a significant proportion of plastic, which is one of the main concerns from an aesthetic perspective if this material is released into the environment. By comparison, sites that are dominated by construction and demolition waste might be less of an issue, even if they are larger in size. So most councils around New Zealand hold a list of closed landfills in their districts, and if they don't have a list, I would suggest they look a bit harder because these sites have a habit of showing up when you least expect it. A smaller number of councils have carried out some form of risk assessment in order to assist with the ongoing management of these sites. These closed landfill risk assessments commonly cover issues like leachate generation, landfill gas generation, and risks to site users. They don't typically cover closed landfill hazards, however they probably hold a lot of the information that you need to understand risks from these particular hazards. So taking an honest look at the sites in your portfolio and the level of information that you hold is a good place to start. Once you know a little about your sites, the next step is to cross-check the landfill locations against hazard information, flood hazard information, and climate change mapping work that might have been done for your region. There's also national level information that's available to help with this. This is the start of understanding what these new risks mean for our old sites. Personally, I think one of the most important things is to ensure that one team is responsible for these sites. You don't all have to be obsessed with closed landfills like I am, but it's important that these sites get regular attention and that all the information is held in one place. The Contaminated Land and Waste Special Interest Group is working with the Ministry for the Environment, Department of Conservation and Local Government New Zealand to develop a risk assessment tool that will help councils to identify landfills that might be exposed and vulnerable to climate change and associated natural hazards. TNT has been working with this group to develop and test the tool across Canterbury, Southland and West Coast. And this work is being led by Environment Canterbury. It's hoped that the tool will provide a nationally consistent way for councils and other organisations to assess risks from climate change, from specific climate change and natural hazards. With tools like this, we can ensure a consistent approach to the assessment of climate change risks to our closed landfills. We can carry out targeted investigations which are relevant to helping understand these risks and make scientifically justified decisions in relation to their management. In this way, we can reduce the impact of legacy landfills on our environment.